In lesson 12.2, we look at a couple other ways to come up with totals, namely permutations and combinations. In number 12, they ask you to use the formula to make the calculation for a permutation 8, 2. So according to the equation, we're going to put n factorial on top. So that'll be 8 factorial. And then on the bottom of your fraction is n minus r, so that would be 8 minus 2 factorial. 8 factorial over 6 factorial means everything from 6 on down will disappear. So you're only left with 8 times 7, or 56. When we use a combination versus a permutation depends on whether order matters or not. In number 22, it says the winner and first, second, and third runner-ups in a contest with 10 finalists. Well, is there a difference between winning first versus second? There is. So order matters. That means we have a permutation, and we're going to be taking winner, first, second, and third. So we're taking 4 of them out of a total of 10. Once we know which calculation to use, we'll go to the formula. Permutation means n factorial on top, so 10 factorial, over n minus r, so 10 minus 4 factorial, which is 6 factorial. Everything from 6 on down will disappear, leaving 10 times 9, 8, and 7. When you multiply those 4 together, you get 5,040 different ways of choosing those 4 places. For 31, we have how many different arrangements of the letters of the Hawaiian word aloha are possible. Altogether, there are 5 letters in aloha. So one thing we could say is that there's 5 factorial ways of ordering those. 5 options for the first letter, then 4, 3, 2, 1. However, when you look at aloha, one way of rearranging it is this. Aloha again. At first it doesn't look like I did anything different, but what I tried to do is switch the 2 A's, but you couldn't tell the difference. When you have something like that, a rearrangement where you can't tell the difference, we have to lessen the total. 2 letters are repeated, so we're going to take 5 factorial and divide it by 2 factorial. 2 and 1 will cancel out, leaving us 5 times 4 times 3, or a grand total of 60 different ways of arranging those letters. Next, number 23. Selecting 2 of 8 employees to attend a business seminar. If we're selecting 2 of 8, it doesn't really matter the order that we select them, because if one person is selected first versus being selected second, it's still the same 2 people going to the seminar. So if order doesn't matter, it's a combination where we're selecting 2 of them, and our population is 8 employees. For combinations, the formula is very similar to a permutation. It's n factorial on top. It's n minus r on the bottom. But then there's also an r factorial. So we have 8 factorial over 6 factorial 2 factorial. 6, 5, 4, 3, 2, 1 will all cancel out, leaving 8 times 7 on top, 2 times 1 on the bottom, for a total of 28 different ways of selecting the 2 people for the seminar. Last but not least, number 25. Placing an algebra book, a geometry book, a chemistry book, an English book, and a health book on a shelf. So here, the order matters because if I put the algebra book first, it looks different than if I put the algebra book last. So that's going to be a permutation. Eventually, I'm placing all 5 books out of the 5. So for my calculation, it'll be 5 factorial over 5 minus 5 factorial, which is 5 factorial over 0 factorial. Anytime you have 0 factorial, that's the same as 1. So 5 factorial over 1 gives me 120 different ways of arranging the books.